This is AP Calculus 6-9, Part 2, and today we're going to cover definite integrals using substitution. This is very similar to the last section. The only difference is instead of having an indefinite integral, we will have definite integrals with the a and b. And remember, if you're doing a problem like this, your a has to be the smaller number, your b has to be the higher number, and they have to be in that order. If they're not, you have to switch them and put a negative in front. But normally in this section, it's just a pretty straightforward. We integrate and then find the answer by plugging in. So the first thing we're going to do is integrate this by using u-substitution. And remember, in the last section we said that whatever is to a power is most of the time what you use as your u. So I'm going to let u equal x squared plus 1. And so my du, the derivative of the u, would be 2x dx. So you may notice that we've got the x squared plus 1, that is my u, and that will be u cubed. And then I have an x dx, but I need the 2 to have the du part there. So I'm going to put a 2 in front, and I'm going to offset that with a 1/2 on the outside so that I haven't changed the value of the original problem. And then I'm going to do my u substitution. So I've got 1/2 from -1 to 1, u cubed du. That's a pretty simple integration. That would be u to the 4th over 4, and then we still have it times the 1/2. It's going from -1 to 1. And then I'm going to re-substitute. My u was x squared plus 1, so I have 1/8 times x squared plus 1 to the 4th, going from -1 to 1. When I plug 1 in, I get 2. 2 to the 4th is 16. 16 times 8 is 2. When I plug -1 in, I get 2 again. To the 4th is 16 times 1/8 is 2. So I end up getting a 0 for that one. For this one, remember we said that if you have a trig function with an x value, your u is most of the time going to be that x value. So I'm going to let u equal 2/3 x. And so my du is 2/3 dx. So I have, when I sub in the u, cosine of u, I have the dx, but I need a 2/3. I'm going to offset that with a 3/2. So I will keep that 3/2, and now I have the du. So that's the antiderivative of cosine u du with a 3/2 tagged in the front. When I take the antiderivative, the derivative of sine is cosine, so the antiderivative of cosine will be sine. So I've got 3/2 sine u going from 0 to pi over 2. U is 2/3 x, so I'm going to substitute that back in. And then I'm going to plug in my angle values. So if I plug in, I've got 3/2 sine pi over 2 times 2/3 is pi over 3, minus, when I plug 0 in, I've got 3/2 sine 0, and then I need a unit circle. Let's see, pi over 3 is 60 degrees. At 60 degrees, we go 1/2 square root of 3 over 2. So sine at pi over 3 is square root of 3 over 2. So we've got 3/2 times square root of 3 over 2, minus sine at 0, that is at 1, 0, is 0. So we've got 3/2 times 0. So we end up with 3 square root of 3 over 4 minus 0, which is just 3 square root of 3 over 4. For this one, I've got a 4 minus x squared underneath my cubed root. That's what my u is going to be, 4 minus x squared. If I take the derivative of that and get my du, I would have a -2x dx. Now, hopefully you notice, we have the x dx here, but we don't have that -2. I'm going to tag a -2 in front, and when I do that, I'm going to offset it with a -1/2, so that I've really just multiplied by 1 and I haven't changed the value of my problem. Then I do the u substitution. I've got -1/2 going from 0 to 2 of u to the 1/3 du. So if I integrate this, I'm going to have a u, 1/3 plus 1 is 1/3 plus 3/3, which is 4/3. So that's u to the 4/3 over 4/3, which would be times a 3/4. And then we've got that negative 1/2, and that is integrated from 0 to 2. Then I'm going to resubstitute in. So let's see, negative 1/2 times 3/4 is negative 3/8 times u was 4 minus x squared to the 4/3. And that's going from 0 to 2. So if I plug 2 in, 4 minus 4 is 0. So we got negative 3/8 times 0 is 0. When I plug 0 in, 4 minus 0 is 4. So we have a 4 to the 4/3. And that's times negative 3/8. So this would be minus a negative, which would be a plus. So this is going to be a positive 3/8 times 4 to the 4/3. And at this point, there's really nothing else I can do. I would plug that into Desmos and get the decimal equivalent for that. There's nothing you can do to solve that, because you can't take a cube root of 4 without it being a decimal. So when I put it in Desmos, I get 2.381 is my answer. And that's going to happen sometimes. They're not all going to be nice, clean whole numbers. Sometimes you'll end up with a decimal. I tend to always round to 3 decimal places because that's what the AP test is usually going to require. But just read the directions and they'll tell you what to do with it. Again, usually what we put, or what we define our u as, is what is to a power. So I'm going to let u equal 1 plus the square root of x. If that's the case, then du is going to be the derivative of that. Well, the derivative of 1 is 0. The derivative of the square root of x, that would be x to the 1/2. So if we take the derivative of that, we would have 1/2 x to the negative 1/2 dx. So if you think about what that would be equal to, our du is going to be 1 over 2 square root of x dx. Now understand, this is the same thing as having a 1 here over all of this dx. The dx on top is nothing new, or is nothing different. It just looks a little bit different. That on top and this beside here, that's really the same thing as dx over 2 square root of x. Those things are interchangeable. You can put the dx on top if there's just a 1 up there, or you can put it to the side. Either way works. So if you think about this, we have the u here. So on the denominator there, we have a u squared. For our du part, we have the dx and the square root of x, but we're missing the 2. So I'm going to pick a 2, or put a 2 right there. Now, what we've really done is we've multiplied this by 1/2. To offset a multiplication of 1/2, I'm going to multiply the whole thing by 2. So that I really only multiplied by 1, and I'm not changing the value of the problem. So if I do that, this is my du. So du, I would say, is on the top. So I've got the integral from 1 to 9 of 2 times du over u. I will do a rewrite. That's 2 times the integral of 1 to 9 of u to the negative 2 du. And now it's really easy to take the derivative of. If I add 1, I will have 2, and that is u to the negative 1 over negative 1 from 1 to 9. I resubstitute. Understand that is the same thing as a negative 2 over u from 1 to 9. If I rewrite, then I'm going to resubstitute. So I've got negative 2 over 1 plus square root of x from 1 to 9. So if I sub in, I've got a negative 2 over 1 plus 3, which is 4, minus a negative 2 over 1 plus 1, which is 2. So I have a negative 1/2 plus 1, which would be an answer of 1/2. This one is a little bit different in that when we go to do some u substitution, we're going to be missing some information, and we're going to have to use what we choose as our u to try and solve the problem. So again, usually what's underneath or what is to a power is going to be your u part. So I'm going to let u be 2 minus x. So that means my du is going to be a negative dx. Well, I have a dx here, but it's a positive dx. So if I put the negative in front, I can offset it with a negative on the outside. Now I have my negative dx. And if we go to substitute, everything's going to look normal at first. When I do my u substitution, u is 2 minus x. So this is u to the 1/2. My du is negative dx. So there's my negative dx. So I've got my du. But I've got this extra x minus 1 that I can't substitute for, at least not yet. So I need everything in this integral to be in terms of u. I need to get rid of all the x's because I can't integrate if I have more than one variable. So what I need to do is I need to go up here and I need to consider what I've got u as. And here I need this x in terms of u. So couldn't I go up here and solve this for x and then replace that x with what I get? Okay, that's still a u substitution. It's just going beyond what we've done so far. So if I do that, I'll have I'm going to move the x to the other side so it's positive. Wouldn't x be equal to 2 minus u, doing a little simple algebra? So if x is 2 minus u, now I can substitute that x with a u. It's going to look a little different than what we're used to, but it'll still work. So x is 2 minus u. Then I've got minus 1. U to the 1/2 du. Now my u substitution is complete. I can simplify it a little bit and do the integration. So I've got negative going from 1 to 2. 2 minus 1 is 1. So we've got 1 minus u times u to the 1/2. In order to integrate that, I want to distribute that u to the 1/2. So I've got the negative going from 1 to 2. U to the 1/2 times 1 is u to the 1/2. Minus u to the 1/2 times u is u to the 3/2. That du applies to the whole thing. Now I can integrate. So I keep my negative. U to the 1/2, the integration of that would be u to the 3/2 times 2/3. Minus the integration of u to the 3/2 would be u to the 5/2 times 2/5. Because remember, it's 1/2 plus 1 is 3/2 divided by 3/2, which means we invert multiply by 2/3. U to the 3/2, 3/2 plus 1 is 5/2, divided by 5/2 would be times 2/5. And that's going from 1 to 2. So I'm going to move up here. I'm going to resubstitute, so I'm going to replace u with what it equals. So I've got 2/3, u is 2 minus x, to the 3/2, minus 2/5 times 2 minus x, to the 5/2, going from 1 to 2. Now if I substitute in, I'm going to plug 2 in first. So I have a negative 2/3. 2 minus 2 is 0. 0 to the 3/2 is 0. 2/5. 0 to the 5/2 is 0. So that whole thing is just going to be 0. Minus, and that's going to be minus a negative. When I plug 1 in, 2 minus 1 is 1. 1 to the 3/2 is 1, and 1 times 2/3 is 2/3. Minus, when I plug 1 in, I've got 1 to the 5/2 is 1. 1 times 2/5 is 2/5. And so I've got a negative 0, which is just 0, plus 2/3 minus 2/5. 15 would be a common denominator. And it would not surprise me if they gave you this on the AP test and wanted you to do it by hand without a calculator. So you need to know how to get simple fractions and get their denominator. So 3 times 5 is 15, 2 times 5 is 10, 5 times 3 is 15, 3 times 2 is 6. So 10/15 minus 6/15 would be 4/15. as my final answer. Certainly if they said you could use a calculator, you would just plug that into Desmos or your calculator and get the answer that way. So I've got two integration problems here. I want you to pause the video, see if you can do these on your own, and then I'll come back in a few minutes and give you the answers. This one's pretty straightforward, so I just stuck everything up here to give you the answer. It's 38. U is 5x plus 1. Du is the derivative of that, which would be 5 dx. Now notice here I had a 15 over 2. I want that to be a 5. So I just took out a 3 halves. Isn't 3 halves times 5 15 halves? So I just brought out what I didn't need to the front. Now you could have brought out the 15 halves and then multiplied by 5 and then times the 1/5 on the outside. It would give you the same thing in the end. Either way is fine, whatever's easiest for you. So then I did the u substitution. So let's see, 5 dx is the du, so the du was on top. This is u, the fourth root of u on the bottom. So that is u to the negative 1/4. When I integrate that, I have u to the 3/4 over 3/4, which is times 4/3, and we've got the times 3 halves. We're going from 16 to 3, and I need to re-substitute. So u is the 5x plus 1 to the 3/4. This simplifies to a 2. So when I plug in 16 times 5 is 80. 80 plus 1 is 81. So I have 81 to the 3/4 times 2 minus, when I plug 3 in, I get 16. So I have 16 to the 3/4 times 2. So I end up with 54 minus 16, which is 38. So nice whole number answer for that one. Wasn't too bad. For this one you have to do u substitution, and then you have to define what x is. So if I were to try to do this one, I have my u, that would be u to the 1/2. My du is 2 dx. I have a dx, but I don't have a 2. So I'm going to need to put a 2 in front, offset that with a 1/2 so that I have my 2 dx for my du part. And then notice I won't have substituted that extra x yet. So that's u to the 1/2, 2 dx is du, but I still have that extra x that I have not been able to substitute yet. So I went up here and I decided what x is. If I subtract 1 from u and then divide by 2, I will have what x is. So I can replace x with what it equals. So if I do that in the next step, I have, that's a 1/2 u minus 1/2 as my x, and that's times u to the 1/2 du. So I'm going to distribute the u to the 1/2. So I have a 1/2 times the integral of 1/2 u to the 3 halves minus 1/2 u to the 1/2 times du. And let's see, that integration goes from 1 to 5 for all of those. So before I integrate, I'm going to distribute that u to the 1/2. So when I do that, I've got a 1/2 on the outside. That would be 1/2 u to the 3 halves minus 1/2 u to the 1/2. Next, I would integrate. I still have the 1/2 on the outside. When I integrate, I have u to the 5 halves times 2/5, and that's times 1/2, minus, that would be u to the 3 halves times 2/3, and that's still times the 1/2. And then that goes from 1 to 5. I'm going to then resubstitute. So I've got a 1/2, and I'm going to multiply this 1/2 times all of these terms as I resubstitute. So my u is 2x minus 1. So I've got 2x minus 1 to the 5 halves. Now, 1/2 times 2/5 is just 1/5, and 1/5 times 1/2 is 1/10. So that's the number in front. Minus, that would be 2x minus 1 to the 3 halves. And then 1/2 times 2/3 is 1/3. 1/3 times 1/2 is 1/6. That is still going from 1 to 5. So now I can substitute my a and b in and find my answer. So when I plug 5 in, 2 times 5 is 10. 10 minus 1 is 9. So we've got 9 to the 5 halves. Well, the square root of 9 is 3. 3 to the 5th is 243. So we've got 243 over 10. If I plug 5 in here, I've got 9 to the 3/2. 9, the square root of 9 is 3. 3 cubed is 27. That's 27 times 1/6, which would be 27 over 6 or 9/2. So that would be minus 9/2. Then we subtract what we get when we plug in 1. So 1 times 2 is 2. 2 minus 1 is 1. So 1 to the 5/2 is 1. 1 times 1/10 is 1/10. Minus, that's 1 to the 3/2 is 1 times 1/6 is 1/6. At this point, I would plug all of that into my calculator and get my answer, which is 428 over 15. I would not look for them to give you one like this without a calculator. I think it's just fine to do a calculator there, but you should know how to get a common denominator just in case.